Part 2. Securing your server with a firewall. In Chapter 4, Securing your shell with a firewall, Part 1, we discovered IP tables and NF tables, which are management utilities that directly interface with NetFilter. Although it is helpful to be familiar with IP tables and NF tables commands in order to create advanced firewall configurations, having to use these commands all the time can become a bit unwieldy for performing normal day-to-day operations. In this chapter, we'll look at UFW and Firewall Day, which are helper utilities that can simplify the process of working with either IP tables or NF tables. First, we'll look at the uncomplicated firewall, or UFW. We'll look at its structure, its commands, and its configuration. Then, we'll do the same for Firewall Day. In both cases, you'll get plenty of hands-on practice. We will cover the following topics in this chapter: UFW for Ubuntu systems, Firewall Day for Red Hat systems. One thing you'll notice is that dealing with either UFW or Firewall Day is somewhat simpler than dealing directly with either IP tables or NF tables. So, you might be wondering why the chapter with the more complicated stuff comes before this one. Well, it's just that UFW and Firewall Day are not standalone programs. Instead, they both use either IP tables or NF tables as their backend. All the versions of Linux come with IP tables, so running either a UFW command or a Firewall Day command as applicable would cause IP tables to run its own corresponding command in the background. The same thing is true for newer Linux versions that come with NF tables. So in order to get the most out of your experience with their UFW and Firewall Day, you'll need to have a good understanding of IP tables and NF tables. So with that out of the way, let's get started. Technical requirements. The code files for this chapter are available here. The uncomplicated firewall for Ubuntu systems. The uncomplicated firewall, UFW, is already installed on Ubuntu 20.04 and Ubuntu 22.04. It still uses the IP tables backend on Ubuntu 20.04 and the NF tables backend on Ubuntu 22.04. For normal operations, it offers a vastly simplified set of commands. Perform just one simple command to open the desired ports and another simple command to activate it, and you have a good basic firewall. Whenever you perform a UFW command, it will automatically configure both the IPv4 and the IPv6 roles. This alone is a huge time saver, and much of what we had to configure by hand with either IP tables or NF tables is already there by default. Although our two versions of Ubuntu use different backends, UFW configuration is identical for both of them. UFW is also available for Debian and other Debian-based distros, but it might not be installed. If that's the case, install it by issuing the sudo apt install UFW command. Configuring UFW. On both Ubuntu 20.04 and Ubuntu 22.04, the UFW service is already established by default, but the firewall itself isn't activated. In other words, the system service is running, but it isn't enforcing any firewall rules yet. I'll show you how to activate it in just a bit, after we go over how to open the ports that you need to open. Check the UFW status with these two commands. systemctl status UFW sudo UFW status. The systemctl command should show you that the service is enabled, and the UFW command should show you that the firewall is inactive. The first thing we want to do is open port 22 to allow connections to the machine via secure shell, like so. Sudo UFW allow 22/TCP. Okay, that looks good. Let's now activate the firewall like this. Sudo UFW enable. By using sudo iptables-l on Ubuntu 20.04, you'll see that the new secure shell rule shows up in the UFW user input chain. On Ubuntu 22.04, use the sudo nft list rule set command to see the new rule in the UFW user input chain. You'll also see that the total output of both of these commands is quite lengthy because so much of what we had to do with bare IP tables or NF tables has already been done for us with the UFW. In fact, there's even more here than what we did with IP tables and NF tables. For example, with UFW we already have rate limiting rules that help protect us against denial of service attacks, and we also have rules that record log messages about packets that have been blocked. It's almost a no-fuss, no-muss way of setting up a firewall. I'll get to that almost part in a bit. In the preceding sudo UFW allow 22/TCP command, we had to specify the TCP protocol because TCP is all we need for secure shell. We can also open a port for both TCP and UDP just by not specifying a protocol. For example, if you're setting up a DNS server, you'll want to have port 53 open for both protocols. You'll see the entries for port 53 listed as domain port. On either version of Ubuntu, do sudo UFW allow 53. On Ubuntu 20.04, view the results by doing sudo iptables/l. On Ubuntu 22.04, view the results by doing sudo nft list rule set. If you do sudo ip6tables-l on the 20.04 machine, you'll see that a rule for IPv6 was also added for both of the two preceding examples. And again, you'll see that most of what we had to do with the IP6 tables commands has already been taken care of. It's especially nice that we don't have to mess around with setting up all of those pesky ICMP rules. On the 22.04 machine, the sudo nft list rule set command that you played previously will show you the IPv6 configuration in the UFW6-user-input stanza. To see just a quick summary of your firewall configuration, use the status option. The output should look something like this: sudo UFW status. Next, we'll look at the UFW configuration files. Working with the UFW configuration files, you can find the UFW firewall rules in the etc UFW directory. As you see, the rules are stored in several different files: etc UFW, lsl. At the bottom of the list, you'll see the user6.rules and user.rules files. You can't hand edit either of these two files. You'll be able to save the files after you made edits, but when you use sudo UFW reload to load the new changes, you'll see that your edits have been deleted. Let's look into the user.rules files to see what we can see there. As you'll soon see, all of the files for both Ubuntu 20.04 and 22.04 contain firewall rules that are in the IP tables format, even though 22.04 uses NF tables as its backend. That's because Ubuntu 22.04 can automatically translate IP tables rules into NF tables rules. So the files for both 20.04 and 22.04 are identical, which makes things very easy for us. At the top of the file, you'll see the definition for the IP tables filter table, as well as the list of its associated chains. Next, in the rules section, we have the list of rules that we created with the UFW command. Here's what our rules for opening the DNS ports look like. As you see, UFW uses IP table syntax for its configuration files, even on Ubuntu 20.04. Below the rules section, we see the rules for login messages about any packets that the firewall has blocked. These messages get sent to the varlog kernel log file so that we don't overwhelm the login system with lots of packets that are getting blocked. We'll only send 3 messages per minute to the log file with a burst rate of 10 messages per minute. Most of these rules will insert a UFW block tag into the log message, which makes it easy for us to find them. The last rule creates messages with a UFW allow tag, and curiously enough, the invalid rule doesn't insert any kind of tag. Lastly, we have the rate limiting rules, which allow only 3 connections per user per minute. Any packets that exceed that limit will be recorded in the var.log kernel log file with a UFW limit block tag. The etc UFW user 6 rules file looks pretty much the same, except that it's for the IPv6 rules. Anytime you create or delete a rule with the UFW command, it will modify both the user.rules file and the user6.rules file. To store rules that will run before the rules in the user rules and user6 rules files, we have the before rules files and the before6 rules file. To store rules that will run after the rules in the user rules and user6 rules files, we have, you guessed it, the after.rules files and the after6.rules files. If you need to add custom rules that you can't add with the UFW command, just hand edit one of these pair of files. We'll get that in a moment. If you look at the before and after tables, you'll see where so much has already been taken care of for us. This is all the stuff that we had to do by hand with either IP tables, IP6 tables, or NF tables. However, as you might know, there's one slight caveat to all this UFW goodness. You can perform simple tasks with the UFW utility, but anything more complex requires you to hand edit a file. This is what I meant when I said that UFW is almost no fuss, no muss. To see more examples of what you can do with the UFW command, view its man page by doing man UFW. For example, in the before files, you'll see that one of the rules for blocking invalid packets has already been implemented. Use the code snippet from the before.rules file, which you'll find near the top of the file. The second of these two rules actually drops the invalid packets, and the first rule locks them. But as we have already seen in the And Overview of IP Table section of Chapter 4, Securing Your Server with a Firewall Part 1, this one particular drop rule doesn't block all of the invalid packets, and for performance reasons, we'd rather have this rule in the mangle table instead of in the filter table where it is now. To fix that, we'll edit both of the before files. Open the etc UFW before rules files in your favorite text editor and look for the following pair of lines at the very bottom of the file. Just below the commit line, add the following code snippet to create the mangle table rules. Now we'll repeat this process for the etc UFW before 6 rules file. Then we'll reload the rules by doing sudo UFW reload. By using the IP tables-L and IP6 tables-L commands on Ubuntu 20.04 or the nft list ruleset command on Ubuntu 22.04, you'll see the new rules show up in the mangle table just where we want them to be. Hands-on lab for basic UFW usage. You'll need to complete this lab on a clean snapshot of either an Ubuntu 20.04 or an Ubuntu 22.04 virtual machine. Let's get started. Shut down your Ubuntu virtual machine and restore the snapshot to get rid of all of the IP tables or NF tables stuff that you just did. Or if you prefer, just start with a fresh virtual machine. When you've restarted the virtual machine, verify that the IP tables rules are now gone. On Ubuntu 20.04, do sudo IP tables-L. On Ubuntu 22.04, do sudo nft list ruleset. View the status of UFW, open port 22 TCP and then enable UFW. Then view the results. Sudo UFW status, sudo UFW allow 22/TCP, sudo UFW enable, sudo UFW status. On Ubuntu 20.04, do sudo IP tables-L, sudo IP6 tables-L. On Ubuntu 22.04, do sudo nft list ruleset. This time open port 53 for both TCP and UDP. Sudo UFW allow 53, sudo UFW status. On Ubuntu 20.04, do sudo IP tables-L, sudo IP6 tables-L. On Ubuntu 20.04, do sudo nft list ruleset. cd into the etc UFW directory. Familiarize yourself with the contents of the files that are there. Note that the second pre-routing command wraps around on the printed page. Repeat step 6 for the etc UFW before 6 rules file. Reload the firewall with this command, sudo UFW reload. On Ubuntu 20.04, observe the rules by doing sudo IP tables-L, sudo IP tables-L mangle-L, sudo IP6 tables-L, sudo IP6 tables-T mangle-L. On Ubuntu 22.04, observe the rules by doing sudo nft list ruleset. Take a quick look at the UFW status, sudo UFW status. That's the end of the lab. Congratulations! I think you'll agree that UFW is pretty cool technology. Its commands for doing basic things are easier to remember than the equivalent IP tables or NF tables commands, and it takes care of both IPv4 and IPv6 with just a single command. On either of our Ubuntu versions, you can still do some fancy stuff just by hand editing the UFW configuration files. But UFW isn't the only cool firewall manager that's available. In the next section, we'll take a look at what the Red Hat folk have given us. Firewall D for Red Hat systems. For our next act, we turn our attention to Firewall D, which is the default firewall manager on Red Hat Enterprise Linux 7 through 9 and all of their offspring. As we just saw with UFW on Ubuntu, Firewall D can be a front-end for either IP tables or NF tables. On RHEL CentOS 7, Firewall D uses the IP tables engine as its backend. On the RHEL 8 and 9 type distros, Firewall D uses NF tables as its backend. Either way, you can create roles with normal IP tables or NF tables commands, while Firewall D is enabled because Firewall D stores the roles in an incompatible format. Until very recently, Firewall D was only available for the newer Red Hat Enterprise Linux versions and their offspring. Now, however, Firewall D is also available in the Ubuntu repositories. So if you want to run Firewall D on Ubuntu, you finally have that choice. Also, the combination of Firewall D and NF tables now comes already installed and activated on the SUSE distros. If you're running Red Hat, CentOS or Alma Linux on a desktop machine, you'll see that there's a GUI front-end for Firewall D in the Applications menu. On a text mode server, though, all you have is the Firewall D commands. For some reason, the Red Hat folk haven't created an ncurses type program for text mode servers as they did for IP tables configuration on all the versions of Red Hat. The big advantage of Firewall D is the fact that it's dynamically managed. That means that you can change the firewall configuration without restarting the firewall service and without interrupting any existing connections to your server. Before we look at the differences between the Red Hat Enterprise Linux 7, CentOS 7, and the RHEL Alma Linux 8 and 9 versions of Firewall D, let's look at the stuff that's the same for both. Verifying the status of Firewall D. For this section, you can use a CentOS 7, Alma Linux 8 or Alma Linux 9 virtual machine. Let's start by verifying the status of Firewall D. There are two ways to do this. The first way is to use the state option of the firewall CMD. Sudo firewall-cmd state running. Alternatively, if we want a more detailed status, we can just check the daemon the same as we would for any other daemon or systemd machine. Sudo systemctl status firewall D. Next, let's have a look at Firewall D zones. Working with Firewall D zones. Firewall D is a rather unique animal in that it comes with several pre-configured zones and services. If you look in the user lib Firewall D zones directory of any of your CentOS or Alma Linux machines, you'll see the zone files, all in XML format. cd user system resources lib Firewall D zones ls. Each zone file specifies which ports are to be opened and which ones are to be blocked for various given scenarios. Zones can also contain rules for ICMP messages, forwarded ports, masquerading information, and rich language rules. For example, the XML file for the public zone, which is set as default, looks like this. In the service name lines, you see that the only open ports are for secure shell access and for DHCP-v6 discovery. If you look at the home XML file, you'll see that it also opens the ports for multicast DNS as well as the ports that allow this machine to access shared directories from either Samba servers or Windows servers. The firewall CMD utility is what you would use to configure Firewall D. You could use it to view the list of zone files on your system without having to cd into the file zone directory. Sudo firewall/cmd/git/zones. A quick way to see how each zone is configured is to use the --list-all-zones option. Sudo firewall-cmd-list-all-zones. Of course, this is only a portion of the output because the listing of all zones is more than we can display here. It's more likely that you'll only want to see information about one particular zone. Sudo firewall/cmd/info-zone equals internal. So the internal zone allows the SSH, MDNS, Samba client and DHCP v6 client services. This is handy for setting up client machines on your internal LAN. Any given server or client will have one or more installed network interface adapters. Each adapter in a machine can be assigned one and only one firewall D zone. To see the default zone, do this: sudo firewall -cmd-get-default-zone public. This is great, except that it doesn't tell you anything about which network interface is associated with this zone. To see that information, do this: sudo firewall-cmd-get-active-zones public. Interfaces column enp0s3. When you install Red Hat, CentOS or Linux for the first time, the firewall will already be active with the public zone as the default. Now let's say that you're setting up your server in the demilitarized end zone and you want to make sure that its firewall is locked down for that. You can change the default zone to the DMZ zone. Let's take a look at the dmz.xml file to see what it does for us. So the only thing that the DMZ allows through is secure shell. Okay, that's good enough for now. So let's see the DMZ zone as the default. Sudo firewall-cmd-set zone equals DMZ. Let's verify it. Sudo firewall-cmd-get zone DMZ. And we're all good. However, an internet-facing server in the DMZ probably needs to allow more than just SSH connections. This is where we'll use the firewall D services. But before we look at that, let's consider one more important point. You don't need to use the --permanent option when setting the default zone. In fact, you'll get an error message if you do. You never want to modify the files in the usr-lib firewall D directory. Whenever you modify the firewall D configuration, you'll see the modified file show up in the etc firewall D directory. So far, all we've modified is the default zone. So we'll see the following files in etc firewall D. Sudo ls-l etc firewall D. We can do a diff on those two files to see the difference between them. Sudo diff etc firewall d.conf, etc firewall d.conf.old. So the newer of the two files shows that the DMZ zone is now the default. To find out more about firewall D zones, enter the man firewall d.zones command. Adding services to firewall D zone. Each service file contains a list of ports that need to be opened for a particular service. Optionally, the service files may contain one or more destination addresses or call in any needed modules such as for connection tracking. For some services, all you need to do is open just one port, or the services such as the Samba service require that multiple ports be open. Either way, it's sometimes handier to remember the service name that goes with each service rather than the port numbers. The services files are in the user-lib firewall D service directory. You can look at them by using the firewall cmd command, just as you could with the list of zones. Before we add any more services, let's check which ones are already enabled. Sudo firewall cmd less services. Here, SSH and DHCP-v6-client are all we have. The Dropbox Lansing service would be very handy for us Dropbox users. Let's see which ports this opens. Sudo firewall cmd info service Dropbox Lansing. It looks like Dropbox uses port 17,500 on UDP and DCP. Now let's say that we have our web server set up in DMZ with the DMZ zone set as its default. Sudo firewall cmd info zone DMZ. As we saw previously, the secure shell port is the only one that's open. Let's fix that so that users can actually access our website. Sudo firewall cmd add service HTTP. Success. When we look at the information for the DMZ zone, once more we'll see the following. Sudo firewall cmd info zone DMZ. Here we see that the HTTP service is now allowed through. But look what happens when we add the permanent option to this info command. Sudo firewall cmd permanent info zone DMZ. Oops, the HTTP service isn't here. What's going on? For pretty much every command line as alteration of either zones or services, you need to add the permanent option to make the change persistent across reboots, but without the permanent option, the change takes effect immediately. With the permanent option, you'll have to reload the firewall configuration for the change to take effect. To demonstrate this, I'm going to reboot the virtual machine to get rid of the HTTP service. Okay, I rebooted, and the HTTP service is now gone. Sudo firewall cmd infozone dmz. This time I'll add two services with just one command and specify that the change will be permanent. Sudo firewall cmd permanent add service http https. You can add as many services as you need to with a single command, but you have to separate them with commas and enclose the whole list within a pair of curly brackets. Also, unlike what we just saw with NF tables, we can't have blank spaces within the curly brackets. Let's look at the results. Sudo firewall cmd infozone dmz. Since we decided to make this configuration permanent, it hasn't taken effect yet. However, if we add the permanent option to the infozone command, we'll see that the configuration files have indeed been changed. Sudo firewall cmd permanent infozone dmz. Now we need to reload to the configuration so that it will take effect. Sudo firewall cmd reload success. Now if you run the sudo firewall cmd infozone dmz command again, you'll see that the new configuration is in effect. To remove a service from a zone, just replace add service with remove service. Note that we never specified which zone we're working with in any of these service commands. That's because if we don't specify a zone, firewalld just assumes that we're working with the default zone. If you want to add a service to something other than the default zone, just add the --zone equals option to your commands. And import to firewalld zone. Having the service files is handy, except that not every service that you'll need to run has its own predefined service file. Let's say that you've installed webmin on your server, which requires port 10,000/TCP to be open. A quick operation will show you that port 10,000 isn't in any of our predefined services. pwd, usr, lib firewalld services, grep 10,000 start. So let's just add that port to our default zone, which is still the DMZ zone. Sudo firewall cmd add port 10,000/TCP. Again, this isn't permanent because we didn't include the permanent option. Let's do this again and reload. Sudo firewall cmd permanent add port 10,000 TCP. You can also add multiple ports at once by enclosing the comma separated list within a pair of curly brackets, just as we did with the services. I purposely left out the permanent option, you'll see why in a moment. Sudo firewall cmd add port 636 TCP 637 TCP 638 UDP. And of course you can remove ports from a zone by substituting remove port for add port. If you don't want to type permanent every time you create a new permanent rule, just leave it out. Then when you have done creating rules, make them all permanent at once by typing sudo firewall d runtime to permanent. Now let's turn our attention to controlling ICMP, blocking ICMP. Let's take another look at the status of the default public zone. Sudo firewall cmd infozone public. Toward the bottom we see the ICMP block line with nothing beside it. This means that our public zone allows all ICMP packets to come through. This isn't ideal, of course, because there are certain types of ICMP packets that you want to block. Before we block anything, let's look at all of the ICMP types that are available to us. Sudo firewall cmd get ICMP type. As we did with zones and services, we can view information about the different ICMP types. In this example, we'll look at one ICMP v4 type and one ICMP v6 type. Sudo firewall cmd info ICMP type network redirect. Sudo firewall cmd info ICMP type neighbor advertisement. We're already seeing that we're not blocking any ICMP packets. We can also see if we're blocking any specific ICMP packets. Sudo firewall cmd query ICMP block host redirect. No. We already established that redirects can be a bad thing since they can be exploited. So let's block host redirect packets. Sudo firewall cmd add ICMP block host redirect. Sudo firewall cmd query ICMP block host redirect. Yes. Now let's check the status. Sudo firewall cmd infozone public. Cool, it worked. Now let's see if we can block two ICMP types with just one command. Sudo firewall cmd add ICMP block host redirect network redirect. Success. As before, we'll check the status. Sudo firewall cmd infozone public. This also worked, which means that we have achieved coolness. However, since we didn't include permanent with these commands, the ICMP types would only be blocked until we reboot the computer. So let's make them permanent. Sudo firewall cmd runtime to permanent. Success. And with this, we've achieved even more coolness. Of course, all of my cats already think that I'm pretty cool. Using panic mode. You've just seen evidence that bad people are trying to break into your system. What do? Well, one option is to activate panic mode, which cuts off all network communications. I can just see this now in the Saturday morning cartoons when some cartoon character yells, panic mode activate. To activate panic mode, use this command. Sudo firewall cmd panic on. Of course, your access will be cut off if you're logged in remotely, and you'll have to go to the local terminal to get back in. To turn panic mode off, use this command. Sudo firewall cmd panic off. If you're logged in remotely, there's no need to check the status of panic mode. If it's on, you're not accessing the machine, but if you're sitting at the local console, you might want to check it. Just do sudo firewall cmd panic. That's all there is to panic mode. Logging drop packets. Here's another time saver that you're sure to like. If you want to create log entries whenever packets get blocked, just use the set log denied option. Before we do that, let's see if it's already enabled. Sudo firewall cmd get log denied. It's not, so let's turn it on and check the status again. Sudo firewall cmd set log denied equals all. Sudo firewall cmd get log denied all. We set it up to lock all denied packets, however, you might not always want that. Your other choices are unicast, broadcast, and multicast. So, for example, if all you want is to log blocked packets that are going through multicast address, do this. Sudo firewall cmd set lock denied multicast. Sudo firewall cmd get lock denied multicast. So far, we just set the runtime configuration, which will disappear once we reboot the machine. To make this permanent, we can use any of the methods that we already use. For now, let's just do this. Sudo firewall cmd runtime to permanent. Unlike we saw with the Debian Ubuntu distros, there's no separate kernel log file for all packet denied messages. Instead, the rel type distros log the packet denied messages in the var log messages file, which is the main log file in the rel world. Several different message tags are already defined, which will make it easier to audit logs for drop packets. For example, here's a message that tells us about blocked broadcast packets. The tag is final reject, which tells us that this message was created by the catch-all final reject rule that's at the end of our input chain. The DST 255.255.255 part tells us that this was a broadcast message. Here's another example where I did an nmap null scan against this machine. Sudo nmap sn 192.168.0.8. In this case, I triggered the rule that blocks invalid packets as indicated by the state invalid drop tag. So now you're saying, but wait, these two rules that we just tested aren't anywhere to be found in the firewall deconfiguration files that we looked at so far. What gives? And you're right, the configuration of these default pre-configured rules is something that the Red Hat folk apparently want to keep hidden from us. However, in the following sections that are specific to RHEL, CentOS 7 and RHEL OM Linux 8 or 9 will spoil their fun because I can show you where these rules are. Using firewall rich language rules. What we looked at so far might be all you ever need for general scenarios. But for more granular control, you want to know about rich language rules. Yes, that really is what they're called. Compared to IP tables rules, rich language rules are a bit less cryptic and are closer to plain English. So if you're new to the business of writing firewall rules, you might find rich language a bit easier to learn. On the other hand, if you're already used to writing IP tables rules, you might find some elements of rich language a bit quirky. Let's look at one example. Sudo firewall cmd permanent add rich rule family equals IPv4 source address equals 200.192.0.0/24 service name equals HTTP drop. Here we're adding a rich rule that blocks website access from an entire geographic block of IPv4 addresses. Note that the entire rule is surrounded by a pair of single quotes and the assigned value for each parameter is surrounded by a pair of double quotes. With this rule, we're saying that we're working with IPv4 and that we want to silently block the HTTP port from accepting packets from the 200.192.0.0/24 network. I use the permanent option here because the rich rule commands don't work correctly if I don't use it. Let's see what our zone looks like with this new rule. Sudo firewall cmd permanent info zone DMZ. The rich rule shows up at the bottom. You could just as easily write a rule for IPv6 by replacing family IPv4 with family IPv6 and supplying the appropriate IPv6 address range. Some rules are generic and apply to either IPv4 or IPv6. Let's say that we want to log messages about Network Time Protocol NTP package for both IPv4 and IPv6, and that we want to log no more than one message per minute. The command to create that rule would look like this: sudo firewall cmd add rich rule service name NTP audit limit value 1/m accept. There is of course a lot more to firewall D rich language rules than we can present here, but for now you know the basics. For more information, consult the man page and firewalld.rich language. If you go to the official documentation page for Red Hat Enterprise Linux 8, you'll see no mention of rich rules. However, I've just tested them on a RHEL 8 type machine and a RHEL 9 type machine, and they work fine. To read about rich rules, you need to go to the documentation page for RHEL 7. What's there also applies to RHEL 8.9, but even there's not much detail. To find out more, see the man page on either RHEL CentOS 7, RHEL ARM Linux 8, or RHEL ARM Linux 9. To make the rule permanent, just use any of the methods that we've already discussed. When you do, the rule will show up in the XML file for the default zone. In my case, the default zone is still set to public. So let's look in the etc firewall D zone's public XML file. Our rich rule shows up in the rule family block at the bottom of the file. Now that we've covered what's common between the RHEL CentOS 7 and the RHEL CentOS ARM Linux 8.9 versions of firewall D, let's look at what's particular to each different version. Looking at IP tables rules in the RHEL CentOS 7 firewall D. RHEL 7 and its offspring use the IP tables engine as the firewall D backend. You can't create rules with the normal IP tables command as long as firewall D is enabled. However, every time you create a rule with firewall D cmd command, the IP tables backend creates the appropriate IP table rule and inserts it into its proper place. You can view the active rules with IP tables/L. Here's the first part of a very long output. As was the case with UFW on Ubuntu, a lot has already been configured for us. At the top in the input chain we see that the connection state rule and the rule to block invalid packets are already there. The default policy for the chain is accept, but the final rule of the chain is set to reject, that isn't specifically allowed. In between these we see rules that direct other packets to other chains for processing. Now let's look at the next portion. Toward the bottom of the very long output, we see the in public allow chain, which contains the rules that we created for opening firewall ports. Just below that is the in public deny chain, which contains the reject rule for blocking unwanted ICMP types. In both the input chain and the in public deny chain, the reject rules return an ICMP message to inform the sender that the packets were blocked. Now keep in mind that there's a lot of this IP table-L outputs that we haven't shown, so look at it for yourself to see what's there. When you do, you may ask yourself, what are these default rules stores? Why am I not seeing them in the etc firewall D directory? To answer that question, I had to do some rather extensive investigation. For some truly bizarre reason, the Red Hat fork have left this completely undocumented. I finally found the answer in the usr-lib python 2.7 site packages firewall call directory. Here there's a set of Python scripts that set up the initial default firewall. The script that does most of the work is the ipxtables.py script. If you look inside it, you'll see that its list of IP tables commands matches up with the IP tables-L output, creating direct rules in RHEL CentOS 7 firewall D. As we've seen, anytime we do anything with the normal firewall cmd commands on RHEL CentOS 7, firewall D automatically translates those commands into IP tables rules and inserts them into proper place. Or it deletes the rules if you've issued some sort of delete command. However, there are some things that we can't do with the normal firewall D cmd commands. For example, we can't use normal firewall D cmd commands to place rules in a specific IP table chain or table. To do things like that, we need to use direct configuration commands. The firewalld.direct man page and the documentation on the Red Hat site both warn you to only use direct configuration as an absolute last resort when nothing else will work. That's because, unlike the normal firewall cmd commands, the direct commands won't automatically place your new rules into the proper places so that everything works correctly. With the direct commands, you can break the whole firewall by placing a rule in the wrong spot. In the example output of the previous section in the default rule set, you saw that there's a rule in the filter table's input chain that blocks invalid packets. In the blocking invalid packets with IP tables section of chapter 4, securing your server with a firewall part 1, you saw that this rule misses certain types of invalid packets. So we'd like to add a second rule to block what the first rule misses. We'd also like to place these rules into the pre-routing chain of the Mangle table in order to enhance firewall performance. To do this, we need to create a couple of direct rules. This isn't hard if you're familiar with normal IP table syntax, so let's get to it. First, let's verify that we don't have any effective direct rules, like so. Sudo firewall cmd direct get rules IPv4 Mangle pre-routing, sudo firewall cmd direct get rules IPv6 Mangle pre-routing. You should get no output for either command. Now let's add our two new rules for both IPv4 and IPv6 with the following four commands. Sudo firewall cmd direct add rule IPv4 Mangle pre-routing 0-m contract ct state invalid jdrop. Sudo firewall cmd direct add rule IPv4 Mangle pre-routing 1 peace tcp exclamation mark sin m contract ct state new jdrop. Sudo firewall cmd direct add rule IPv6 Mangle pre-routing 0-m contract ct state invalid jdrop. Sudo firewall cmd direct add rule IPv6 Mangle pre-routing 1 p tcp exclamation mark sin m contract ct state new jdrop. The direct command syntax is very similar to that of normal IP tables commands. So I won't repeat the explanations that I've already presented in the IP table section. However, I do want to point out the 0 and the 1 that come after pre-routing in each of the commands. Those represent the priority of the rule. The lower the number, the higher the priority. And the higher up the rule is in the chain. So the rules with the 0 priority are the first rules in their respective chains, while the rules with the 1 priority are the second rules in their respective chains. If you give the same priority to each rule you create, there's no guarantee that the order will remain the same upon each reboot, so be sure to assign a different priority to each rule. Now let's verify that our rules are in effect. Sudo firewall cmd direct get rules IPv4 Mangle pre-routing 0-m contract ct state invalid jdrop 1 p tcp exclamation mark sin m contract ct state new jdrop. Sudo firewall cmd direct get rules IPv6 Mangle pre-routing 0-m contract ct state invalid jdrop 1 p tcp exclamation mark sin m contract ct state new jdrop. We see that they are. When you use the IP tables t mangle l command and the IP tables t mangle l command, you'll see that the rules show up in the pre-routing direct chain. I'm only showing the output once since it's the same for both commands. To show that it works, we can perform some nmap scans against the virtual machine, just like how I showed you in the blocking invalid packets with IP table section of chapter 4, securing your server with firewall part 1. Don't fret if you don't remember how to do it. You'll see the procedure in the upcoming hands-on lab. Then we can use sudo IP tables tmangle lv and sudo ip6 tables tmangle lv to see the packets and bytes that these two rules blocked. We didn't use the permanent option with these commands, so they're not permanent yet. Let's make them permanent now. Sudo firewall cmd runtime to permanent. Sudo ls-l etc firewall d. Look inside the file, you'll see the new rules. The official RHEL 7 documentation page does cover direct rules, but only briefly. For more detailed information, see the firewall D direct man page. Looking at NF tables, rules in RHEL Linux 8 and 9 firewall D. The RHEL 8, 9 and their offspring use NF tables as the default for firewall D backend. Every time you create a rule with firewall TMD command, the appropriate NF table rule is created and inserted into its proper place. To look at the rule set that's currently in effect, we'll use the same nft command and that we used with nf tables on Ubuntu. Sudo nft list. Again, we see a very lengthy list of default pre-configured firewall rules. To see the whole list, run the command for yourself. You'll find these default roles in the usr lib Python 3.6 side packages, firewall core nf tables with PyScript on RHEL 8 type machines, and in the usr lib Python 3.9 side packages, firewall core nf tables with PyScript on RHEL 9 type machines. The script runs every time you boot up the machine, creating direct rules in RHEL on Linux firewall D. Okay, Here's where things get downright weird. Even though the direct rule commands create IP tables, rules, and the rel 89 distros use NF tables for the firewall D backend, you can still create direct rules. Just create and verify them the same way that you did in the create direct rules in the rel center 7 firewall D section. Apparently, firewall D allows these IP tables rules to peacefully coexist with NF tables rules. However, if you need to do this on a production system, be sure to thoroughly test your setup before putting it into production. There's nothing about this in the rel 89 documentation, but there is the firewall-d.direct man page if you want to find out more. Hands-on lab for firewall-d commands. By completing this lab, you'll get some practice with basic firewall-d commands. Log into your CentOS virtual machine or either of the all Linux virtual machines and run the following commands. Observe the output after each one. Sudo firewall cmd get zones, sudo firewall cmd get default zones, sudo firewall cmd get active zones. Briefly view the man pages that deal with firewall D zones. Man firewall D zones, man firewall D zone. Yes, there are two of them. One explains the zone configuration files while the other explains the zones themselves. Look at the configuration information for all of the available zones. Sudo firewall cmd list all zones. Look at the list of predefined services, then look at the information about the Dropbox LAN sync service. Sudo firewall cmd get services, sudo firewall d info service, Dropbox LAN sync. Set the default zone to DMZ, look at the information concerning the zone, add the HTTP and HTTPS services, and then look at the zone information again. Sudo firewall cmd set default zone DMZ, sudo firewall cmd permanent add service HTTP HTTPS, sudo firewall cmd info zone DMZ, sudo firewall cmd permanent info zone DMZ. Reload the firewall configuration and look at the zone information again. Also look at the list of services that are being allowed. Sudo firewall cmd relate, sudo firewall cmd info zone DMZ, sudo firewall cmd list services. Permanently open port 10,000 TCP and view the results. Sudo firewall cmd permanent add port 10,000 TCP, sudo firewall cmd list port, sudo firewall cmd reload, sudo firewall cmd list port, sudo firewall cmd info zone DMZ. Remove the port that you just added. Sudo firewall cmd permanent remove port 10,000 TCP, sudo firewall cmd reload, sudo firewall cmd list port, sudo firewall cmd info zone DMZ. Add a rich language rule to block a geographic range of IPv4 addresses. Sudo firewall cmd permanent add rich rule family IPv4 source address 201.92.0.0.24 service name HTTP drop. Block the host redirect and network redirect ICMP types. Sudo firewall cmd permanent add ICMP block host redirect network redirect. Add the directive to log all drop packets. Sudo firewall cmd set log denied all. View both the runtime and permanent configurations and note the differences between them. Sudo firewall cmd info zone DMZ, sudo firewall cmd info zone DMZ permanent. Make the runtime configuration permanent and verify that it took effect. Sudo firewall cmd runtime to permanent, sudo firewall cmd info zone DMZ permanent. On CentOS 7, view the complete list of effective firewall rules by doing sudo ip table-l. On Alma Linux 8.9, view the complete list of effective firewall rules by doing sudo nft list rule set. Create the direct rules in order to block invalid packets from the mangle tables pre-routing chain. Sudo firewall cmd direct add rule IPv4 mangle pre-routing 0 and contract CT state invalid J drop. Sudo firewall cmd direct add rule IPv4 mangle pre-routing 1p TCP exclamation mark sin dash m contract CT state new J drop. Sudo firewall cmd direct add rule IPv6 mangle pre-routing 0-m contract CT state invalid J drop. Sudo firewall cmd direct add rule IPv6 mangle pre-routing 1-p TCP exclamation mark sin-m contract CT state new J drop. Verify that the rules took effect and make them permanent. Sudo firewall cmd direct get rules IPv4 mangle pre-routing, sudo firewall cmd direct get rules IPv6 mangle pre-routing, sudo firewall cmd runtime to permanent. View the contents of the direct.xml file that you've just created. Sudo ls etc firewall d direct.xml. Perform xmasts and map scans for both IPv4 and IPv6 against the virtual machine, then observe which rule was triggered by the scan. Sudo nmap-sx IPv address of the test virtual machine. Sudo nmap-6-sx IPv6 address of the test VM. Sudo ip tables-t mangle-l-v, sudo ip6 tables-t mangle-l-v. Repeat step 19, but this time with a Windows scan. Sudo nmap-sw IPv4 address of the test virtual machine. Sudo nmap-6-sw IPv6 address of the test VM. Sudo ip tables-t mangle-l-v, sudo ip6 tables-t mangle-l-v. View the list of main pages of the firewall D, a proposed firewall. That's the end of the lab. Congratulations. Summary. In this chapter, we'll look at the two helper utilities that can simplify using either IP tables or NF tables. We started UFW, which is available for Debian and Ubuntu families. Then we looked at FirewallD, which used to be specific to Red Hat type distros, but is now also available in Ubuntu repositories and comms already installed and activated on the SUSE distros. In the space that I've been allotted, I presented the basics of using these technologies to set up single host protection. I also presented some details about the innards of FirewallD that you won't find documented anywhere else, including in the official Red Hat documentation. In the next chapter, we'll look at the various encryption technologies that can help keep your data private. I'll see you there. Questions? What's the major difference between FirewallD on RHEL 7 type distros and FirewallD on RHEL 8.9 type distros? In which of the following code format does FirewallD store its rules? Text, config, HTML, XML. Which of the following commands would you use to list all of the FirewallD zones on your system? Sudo FirewallD get zones, sudo Firewall CMD list zones, sudo Firewall CMD get zones, sudo FirewallD list zones. With UFW, everything you ever need to do can be done with the UFW utility, true false. Your system is set up with FirewallD and you need to open port 10,000 TCP. Which of the following commands would you use? Sudo firewall cmd add port 10,000 TCP, sudo firewall cmd add port 10,000, sudo firewallD add port 10,000, sudo firewallD add port 10,000/TCP. Which of the following UFW commands would you use to open the default secure shell port? Sudo UFW allow 22, sudo UFW permit 22, sudo UFW allow 22/TCP, sudo UFW permit 22/TCP. Further reading. Rate limiting with UFW, FirewallD documentation for Red Hat Enterprise Linux 7, FirewallD documentation for RHEL 8, the FirewallD homepage, UFW Community Help Wiki, how to set up a Linux firewall with UFW on Ubuntu 18.04. Answers. RHEL 7 distros use IP tables as the FirewallD backend, and RHEL 8.9 distros use NF tables as the FirewallD backend. 2D, 3C, 4B, 5A, 6C.